Hello, ladies and gentlemen. We're going to do a few solving problems. These are on the back of the solving handout we did. So when you're solving, the first thing you want to do is get a common denominator with every denominator in the problem. Now, oftentimes, it's helpful to factor the denominators to see sort of what each denominator needs. So I'm going to start by factoring this quadratic here. That's dots. This is x plus 3, x minus 3. So this denominator has x plus 3, x minus 3. This denominator only has x plus 3, which means he needs an x minus 3. So I'm going to give him an x minus 3 in the top and the bottom. Now this middle term has the same denominator. I'm going to do the same thing with this guy. So we've got a plus sign here, and I have 3 over x minus 3, but this denominator needs an x plus 3. Now they all have the same denominator. That is x plus 3, x minus 3. So what I can do is clear the fraction. If everything has the same denominator, then I can multiply both sides by that denominator. So really algebraically what I'm doing is saying x minus 3, x plus 3. I need to distribute this to the whole side, and I need to do it on the right side as well. Now when you do this, what happens is these all cancel out. And you're only now focusing on the numerator. So this is the only thing that matters in the problem now as far as actually solving it. So when we look at just the top of the fraction, we're going to distribute 3 times x plus 3 is 3x plus 9. We're going to distribute a 1, x minus 3, and on the right side I just have 14. It's a whole lot easier now. You got to combine like terms. 3x plus 1x is 4x, 9 minus 3 is 6. You got to subtract 6 on both sides, and then you got to divide both sides by 4, and you get x equals 2. So x equals 2, which you need to make sure that's not extraneous. Now, I can see right here, the only extraneous answers would be 3 and negative 3, because that would get 0 in the denominator. So 2 does work, and you can plug it in to kind of verify that if you want. You can plug 2 in everywhere you see x. Let's try another one. So we're going to play the same game, 3 over x plus 2. I'm going to have to eventually get a common denominator. I have an x plus 2 here. Oh, I don't have any denominator. I'm sorry. That's just 1. And this guy is negative 5 over. I'm going to factor the bottom. So I need numbers that multiply to negative 10 and add to negative 3. That'd be negative 5 and positive 2. This is a 1x squared, so you can just go straight to the factors. So my factors are x minus 5 and x plus 2. Well, this guy already has an x plus 2, but he needs an x minus 5. You can kind of imagine plus and minus is the same as subtracting. Now this guy has an x plus 2 and x minus 5. X plus 2, x minus 5. This guy needs both. X plus 2, x minus 5. X plus 2, x minus 5. Now that I have the same denominator in every part of the problem, I can multiply both sides by that denominator and clear the fraction. I'm just going to focus on the top. All I'm looking at now is the top of this fraction. So if I distribute on the top, 3x minus 15. This is a little tricky. I'm going to FOIL this. X squared minus 5x plus 2x minus 10. But since we're subtracting, this is a minus sign, we're going to have to distribute a negative. So 3x minus 15, then it'll be minus x squared. This is negative 3, but negative 1 times negative 3 is positive 3, and negative 1 times negative 10 is positive 10. Combine like terms. This is a quadratic, so it's a little bit more work. X squared plus, well, no, it's negative x squared. So maybe we'll move the x squared to the right side. Well, we'll combine like 6x minus 5 minus x squared equals negative 5. So combine like terms. 3 plus 3 is 6. Negative 15 and 10 is negative 5. You have a negative x squared. Let's move everything to the right side. It'll make the x squared positive. So now I have positive x squared, negative 6x, and if you add 5 to both sides, you actually get 0. Negative 5 plus 5 is 0. So that's going to be easy to factor because it's just GCF. X and x minus 6. So x either equals 0 or x equals 6. Are either of those extraneous? No, negative 2 and 5 would be extraneous. So 0 works and 6 works. There's 2 answers. You can plug them in to check. Get a common denominator, then just focus on the numerator. Let's try another one. h plus 3. So this guy has an h plus 3, this guy has an h, and this guy has an h plus 3. So what's everybody need? He needs an h. If you do it in the bottom, you got to do it in the top. He needs an h plus 3. You do it in the bottom, you got to do it in the top. And he needs an h. Now they all have the same denominator, so you can just focus on the numerator. So in the numerator, I have h plus, I have to distribute, 2h plus 6, and on the right side I have 4h. So that's 3h plus 6 equals 4h. If you subtract 3h on both sides, you get 1h, so h equals 6, and that works. The extraneous solutions would be -3 and 0. 6 works. Last one, 6x over x plus 4. I'm going to leave myself some space here, 4 over 1. 2x plus 2 over x minus 1. So there's an x plus 4, there's an x minus 1. He needs an x minus 1. He needs both x plus 4 and x minus 1. So we got x plus 4, x minus 1, x plus 4, x minus 1. Here there's an x minus 1, but he needs an x plus 4. So we're going to have to FOIL a couple times here. So now we're just focusing on the numerator. The denominator gets canceled out, but when you distribute, you get, let's do it black, 6x squared minus 6x plus 4 times, I'm going to FOIL here, x squared minus x plus 4x minus 4. And I have to FOIL on the right side as well. 2x times x is 2x squared. Outside is 8x. Inside is 2x. And last is 8. So we got a lot going on. This one's definitely the hardest to solve. 6x squared minus 6x plus 4x squared. That makes 3x in the middle, and 3 times 4 is 12. A lot of stuff. Combine like terms, that's 10. Okay. Let's get everything on one side. Maybe we'll even combine before we do that. 10x squared plus 6x minus 16 equals 2x squared plus 10x plus 8. All right, so I'm going to subtract all of these terms. 10 minus 2 is 8x squared. 6 minus 10 is negative 4x squared. And negative 16 minus 8 is negative 24. We got a factor. I think it'd be easiest to do GCF first. These are all multiples of 4, and now I have 2x squared minus x minus 6. So I have to do split the middle, or I'm going to try and guess and check because 2 is prime. I need numbers that multiply to negative 12 and add to negative 1. So how can I get a negative 12 and a negative 1? Negative 12 would be 2 and negative 6 and positive 1. That makes 2x squared minus 12. That ain't going to work. Okay, what multiplies to negative 12 and adds to negative 1? Maybe I could try something else. You know what? Maybe let's just do the split the middle. It'll be easier. So I'll just work the whole thing out. 2x squared, I think this makes more sense anyway. Negative 4x plus 3x. There we go. They multiply to negative 12 and they add to negative 1. So 2x, x minus 2 plus 3, x minus 2. So I have 2x plus 3, x minus 2. And then my third factor is the 4. The 4 doesn't really matter because 4 is never 0. So now when does this factor equal 0? That'd be negative 3 halves. And when does x minus 2 equal 0? At 2. Those both work? Yeah, I think so. The extraneous solutions would be negative 4 and positive 1. So negative 3 halves works and positive 2 works. So you need to get a common denominator, then just focus on the numerator, which can be quite a process. In this one, that's pretty long. But that's the whole thing for solving. So if you guys can do those, you should be able to do some practice problems, and good luck.